Welcome back. We've got an interesting episode today. We've got a cast iron radiator repair to do for a customer. We're going to weld it up and then we're going to pressure test it. Stick around. This is what we're working on today. This is just one section of a larger radiator. You can see here these are, each individual piece. So this piece right here is actually that piece there that you see. Then the end is capped at the top. Then the inside would slide onto, another like nippled flange piece like this at the bottom and top. And that's how these all just press together. Then there's a set of long bolts that go down through, or a threaded rod that goes through the whole assembly, and they just tighten down with some nuts. So a long piece of threaded rod just clamps this whole assembly together. If you look right here, you can see there's a crack, and it starts from this hole, extends all the way around this tube, and it continues up this. We're going to start out pressure testing it with air, because air is lighter than water. So if it doesn't leak air pressure, then it's definitely not going to leak with liquid. I think what we're going to do is just take a piece of rubber and place it here. Do the same thing here. Put a piece of rubber over this, then put a steel plate over that, and then just clamp it together so that it basically just sandwiches it under pressure, and then we can put a fitting on one of the pieces and introduce air into it. One of the first things we got to start doing is cleaning this up so we can actually see it. So we'll get in there with a wire brush and get this all wire brushed up. These little pieces of wire have a tendency to fly out, and you also want to make sure that the wire wheel that you're using is compatible with the RPM of your grinder, because they can fly apart and cause all kinds of problems if they're not matched up to one another. Now that we've got it all ground out, you can kind of see it a little bit better. It goes along this right here, and then around. I don't know where it stops over here. It actually kind of looks like it extends along this as well, but I can't tell. Then it comes back around, comes down to here, and it looks like it stops right there, but I can't tell. Got some markings on it. It says American Radiator, and it's got an 11, stamping of 11, and it looks like a 19. And there's another mark here. Looks like maybe 7J or something like that. I think what I'm going to do, so you can see how we have these little areas here. I think what I'm going to do is I'm going to plug these first and pressure test it right now, so I can actually put a little bit of air in this and then apply some detergent in water and see how far back these cracks extend to help give me a good visual. Just real hard to see where that is, because we got to get in here and we got to V and groove this all out wherever that crack is, and we want to make sure we go back far enough and that we follow it, because if it goes all the way back here, we need to go all the way back there. I think the way I'm going to do this is I have an old tire tube for when I rebuilt that 86 TRX on this channel. So I'm going to cut out the valve stem, then I'm going to plate it on this side right here, and I'm going to do the same thing here, just put a little piece of it there, and I'm going to do the same thing over here. I'm sure there's a few other ways that we could do this, but I've got these materials, so this seems like a great way to me to do it. And that leaves me with that right there. I can just set that there, drill a hole through a piece of metal plate, and then just sandwich that together right here. Flip it over and we'll cut another piece for the other side. Even double it up, give it a little more cushion if we wanted to. Now we'll just figure out what size drill bit we're going to need. We'll just take this tool right here, and we'll just bring it down, give it a little bit of slack, you know, something like that right there. Then we'll come down to our drill index and find one that's going to work. There we go. That's it right there. 1/2 inch. And then we're going to want one to do a pilot hole, so let's grab that. Got a little bit of scrap plate hanging around. Not that we have to get it exactly in the center, but right here, might as well. So we'll put a straight edge there. Mark that. Corner to corner to find the center. Mark that. And there's our center line. We'll put a center point on it so it doesn't skip around. Now we got a nice center mark. For those of you new to the channel, this is a mag drill that I've got mounted to a stand that I've modified that I picked up off Facebook Marketplace for $35. I cut the top of it off where the normal drill head would go, and I welded this on and then placed this on top of it. That way it gives me dual purpose tool. I can take this, bring it to the job site, use it mobile, or keep it set up here, and you can run everything with it. You can run hole saws, you can run annular cutters, and you can run drill bits. Having this set up really gives you the best of both worlds. This just makes it so nice to have this. You just turn the magnet on the back, it just sticks the tool right to this plate that I've welded onto the top. Everything's adjustable. This table lifts up and down. The mag drill is not cheap. I really couldn't justify just having a mag drill alone because I don't necessarily have a lot of uses for just a mag drill, but I do have an occasional use. So this being able to serve dual purpose actually is a huge benefit for me. Now we'll chamfer the hole a little bit. I'm just using a chamfering bit. So now this will go over that like that. We'll sit on top like that, then get clamped. We'll remove the valve cap, then we'll just put air in this, and that'll fill this radiator right full of air. All right, so we'll fold a piece of this rubber over on the back side. Set that kind of on it like that. It's going to take a little bit of finagling to get this perfect. And we'll put that on like that. Now we'll put one on the other side. I'll double that over just like that. There. Let's put this up on a couple blocks of wood and see if we can get some air in it. Here I have a little bottle of soap and water, and it's got a little hole in the top. I use this for checking tires and stuff like that. Let's see what we can come up with. If I squirt this on that crack, it should bubble and show us the extent of it. So if you look right here, guys, this crack goes around a lot further than we had expected. Watch. Put a little bit of water in there. It's bubbling way over here, guys. Over here on this side. So it's cracked all the way up there. See it? Oh, it's even spidering up that way. See it way up in there? So that's the end of the crack. It goes from there all the way around. Alright, we're going to do it one more time. Put some air in it, and I'm going to drill it this time so I don't lose it. Okay, the end of it's right there. Drilling it is going to prevent that crack from spreading again. Let's flip it around and check the other side. Throw some more air in it. Alright, this one's easier. It doesn't extend beyond. Okay, now we know where it originates and terminates. We can take off our testing setup, V this out, and start getting this welded. I'm gonna use a carbide burr and work on getting this V'd out, because we gotta grind a V for our weld to go so we can get some good penetration in there. Alright, we got this side pretty good. Let's head back to the first side, just double check everything, make sure we're good. We got this ground out really nice. You can see this is where I started that hole. Then I went back just a little bit further. As you saw, I was using a Dremel tool. This radius right here was giving me problems with that other tool. So I resorted to the Dremel tool for this. It's a little underpowered, but you just go at it nice and slow and it'll work fine. And then I just used the rotary tool all through here, or the carbide burr, I should say, on my drill, and got this all prepped. So this is all ready to go. This is all ready to be welded. So the next thing that we'll do is get the welder set up. We're going to do a preheat on this. So we're going to add a bunch of heat to this right before we weld it. And then we will put this in some sand and do a slow cooling, because cast iron has a tendency to want to crack. We're going to be repairing this with silicon bronze wire. We're going to be using it with a MIG welder, and it's not really considered MIG welding because of the melting temperature, so it's actually MIG brazing. So that's what we're going to do. That'll be perfect for an application like this on a radiator. Once we get this all welded up, like I said, we will cap it back up using our test pieces that we made. We'll introduce some air in it. We'll probably put 5 psi in it, hold it, check it on the gauge, and then we will spray everywhere to make sure we have no leaks on this part. This is a pretty complicated repair, but I'm going to walk you through every step of the way so that you guys will know what to do if you have a cast iron repair, and hopefully it will turn out to be a successful one. So let's get going. But before we get welding, I wanted to show you something. This is a brand new welder from Yes Welder. It's not even available to the public yet. It's got a massive screen on it. It doesn't even come with a pamphlet yet. It's so new that it doesn't even have directions with it. So I've just been messing around with it. I'm not going to use this to repair this here today, just because I don't want to go messing around with a new machine trying to figure it out. Any new machine that you get, whether it's this or anything, or that, any machine is going to take some seat time to get used to it, so you know how the settings work and everything else. And this, like I said, doesn't even have a manual yet. But I do like the intuitive display. You can go down through, you can see this knob pretty much does all of it. You just rotate it for what you want, and when you're there, then you just rotate to the selection you want, and then you press it to select it. And then you can click on your wire diameter. Those are your options there. So yes, just very intuitive. Material thickness. It's got like 50 memories, I believe. 50 memory presets you can store in this. And another thing that I haven't been able to figure out is that you can make this screen either white, so in like white mode, or in dark mode, so it turns it black. And then you select your process, spool gun, MIG torch. It's got a gas purge. This is a double pulse machine. That's one of the advantages of this, so it's going to be awesome for doing aluminum, or awesome for doing very thin metal due to that spot function. As I said, it's spool gun compatible, and what I really like, and I don't know if anybody else is doing that, is it has a little holder in the bottom to hold all your drive rolls. This is a 120, 240 machine, and I believe once this is available to the public, the price is right around 399 bucks or so. So far it looks like a pretty impressive machine, but I just wanted to show it to you guys. Like I said, full disclosure, they sent this to me to check out, and I'm always looking for ways to get people into welding. So naturally, if they want to send me something like this, obviously I'm going to accept it because it's going to get more people interested in welding, and that's what I'm looking for. As always, I like to show you my setup, and I'm using 18 volts, 11.4 meters a minute. I'm using a little over 30 CFH of pure argon gas, and I'm using 30 thousandths Blue Demon silicon bronze. Silicon bronze is an awesome filler metal, especially if you're joining similar or dissimilar metals together. The melting point on this is like 1700 degrees Fahrenheit. I'm going to preheat it, and then we'll start laying in some of this filler metal, and then we will peen it with a peening hammer or a chipping hammer as we go. I'm going to have to grind this down a little bit too, because the bead profile is going to interfere with these nuts that have to go on this. Alright guys, bad news, and you can't win them all. There's only a little section that bonded, and that was it. Other than that, didn't bond at all. So unfortunately, this is white cast iron, and white cast iron can't be repaired. Gray or ductile or any other cast iron can be, but this cannot. Unfortunately guys, this stuff happens when you're working with cast iron. Sometimes you just can't fix it. You do the best you can, hope for the best, and it just doesn't always work out. Whereas it wasn't even bonding at all, and you can just flick it off with a chipping hammer, tells you that it's just not weldable. So as unfortunate as it is, we gave it a try. You can buy cast iron replacement radiators fairly cheap, so they may have to do that, but I think they just figured, let's give it a try if they can. I don't know what caused it to crack. Maybe they over tightened those through threaded rods that hold it all together, or maybe it froze at one point in time. I don't really know. Even a failure is not always a failure when it becomes a learning lesson, and this is just one of those learning lessons that not all cast iron can be fixed. I know I have a pretty good success rate of repairing cast iron, but you know, unless you were the one who actually molded that cast iron and poured those metals into the pot, you don't know what that's made out of. Cast iron is just a bunch of different metals, and it can vary from batch to batch depending on where it was made and who made it. Sometimes there's more carbon content than others, or sometimes there's less, which makes it easier to weld, so you just don't know. Just like anything guys, you win some, you lose some. Some days are better than others. You just keep moving forward. I want to thank you guys for watching. Thank you guys for tuning in. Until the next one, I will see you then. Take care, stay safe, like, comment, subscribe. God bless.